Chapter 2.2 is going to get us into two-step equations. This lesson is meant to take us a step further in our solving. We learn how to solve a one-step equations, so now we can use the fundamental rules to solve two-step equations. This is where it's very important that you at least, after you take these notes, that you at least make sure you master one-step equations first. That is because if you don't know how to do one-step equations, then how can you do equations that have two when all you're doing is making two steps based off of what you were supposed to have learned in the last lesson? So yes, take the notes, make sure you have these notes down, but I would not try the homework from 2.2 until after you finish the homework from 2.1, because until you know how to move numbers appropriately, you will make mistakes if there are more than one decision, or if there's more than one decision. So again, take your time, take the notes to try to understand what's going on, but before you start really getting into this, make sure you take care of homework on 2.1. Also make sure you're asking for help as much as possible. This is where a lot of students start getting left behind because they want to be proud and they don't do what's necessary to make sure that they fill in those gaps that they have, and then things just start piling up. Because trust me when I say this class is going to be moving one lesson per day. So you have, it's not that you'll have one day to learn everything, but everything's just going to kind of stack, and then it's up to you to kind of sort it out as it goes. The difficult part of solving two-step equations is making sure we use the proper order of steps. So that brings us to our essential question, which is how do I determine which step is first in solving a two-step equation? In order to solve, we are going to pretty much undo what has ever been done. And that means we can identify the step by using order of operations to think our way through it. Consider this cheap example. If I am standing here and I go 2 steps up and 3 steps over, if I want to retrace my steps, so I went 2 up and 3 right, if I want to undo that from here, then what I have to do first is take 3 steps left. Notice that I start at the bottom, and then 2 steps down. So again, notice that what I did was took 2 up and 3 right, and then what I did to undo it was started with the 3 with the opposite direction, and then the 2 with the opposite direction. Same thing here. With the order of operations, you are going to pretty much, if you need to think your way through it, which you should just make it muscle memory, but a lot of times if you get stuck, just imagine doing the order of operations and then think whatever is last is the weakest, that is the last thing I'm going to do. So for example, if you look at these equations and you have 5x plus 2 equals 9, and you imagine taking a number and putting it here, based off of order of operations, the first thing we would do is multiply by 5. The last thing we would do is add 2. That means that this is my last step, which means that is the number that should be moved first, not the 5, because I would multiply by 5 then subtract or add 2, which means this is the weakest, which means that's the number that has to go if I'm going to undo this process. Same thing here. If I was to plug a number here, the first thing I would do is divide by 3 and then subtract 4, which means that this, being my last step, is the first step that I want to do to undo it. In this problem, remember that this is a big fraction, which means the first thing you do is add 2, then divide by 5, which means that since that is my last step, that this is actually the first thing I'm going to get rid of. Again, don't worry about that yet. We'll talk about that. But again, in terms of solving, if you have 2 steps, the step you choose is whatever the last step you would do if you were doing the order of operations. So again, if I was going to multiply, then add, then that is where I'm going to start. If I was going to divide, then subtract, then that is where I'm going to start. If I was going to add, then divide, then that is where I start. Just like if I took 2 steps up, 3 steps right, that I started taking 3 steps left to undo it, and then 2 steps down. Again, the opposite operation still comes into play, but you have to make sure that you understand the order of the process that's going there. So once you learn to identify the weakest value, the rest of the job remains the same. Move the value by using this opposite operation. This is why I'm telling you that if you have not mastered the work from section 2.1, then you're going to have issues, because if you're moving things the wrong way, then that's a whole other problem. The process is best learned through examples and practice, so just be sure to take good notes and use them to think your way through the problems you face. When all else fails, be sure to ask questions about whatever you may need. Again, this is not the time to be stubborn. You are pretty much learning the foundational work of a lot of problems that you're going to see later on, And so it's very important that you at least start getting this down so you're ready for the quiz, ready for the test to pop up. Here's your notes. The only new information for the day is in coping with negative variables, because everything else is pretty much the same. We're just giving you two choices, and the best way to solve these problems is to switch all the signs and solve as usual. Now, this is not absolutely necessary. For example, we learned that this is negative 5 times x, which means we could divide by negative 5, but you don't have to do that. We are eventually going to have symbols here that actually flip, and it would be safest if you learn to say this has a negative number attached to x. So what we are going to do is make 5 positive. The equal sign stays, but make this, if you switch to the left, you must also switch to the right, just like whatever you do to the left, you must do to the right. So switching to the left, switching to the right gives me a negative 185, and then I would divide by 5. Remember, this is how we write it on paper, not the way you do on MathXL. And then negative 185 divided by 5 is negative 37. If you saw negative x over 7 equals negative 6, again, you could multiply by negative 7, but that's kind of hard to remember. What I would do is say there is a negative attached to the fraction, so what I'm going to do is switch all the signs, which means this turns into a positive x over 7, which makes this, therefore, a positive 6. And then to get rid of that 7, again, on paper, we write it this way. We're going to multiply by 7, get rid of those 7s, x comes down, equaling 42. If your steps are not under control, you're going to have issues. Again, make sure you start trying to get this down, because this is going to sneak up on you pretty quickly. So the examples we're going to look at is about 6 of them, but there's 6 questions that you need to be ready for. Keep in mind that these numbers can be moved around and swapped around and all kinds of stuff, so just use these examples, plus use the resources, people around you, me, anything you can to make sure you're ready. Either way, 2x plus 1 equals 7. Keeping in mind that if this was here, I would multiply first, add second, which means the first thing I'm going to do is move this 1. So I'm going to use my divisor line here. So I'm going to move the 1. Again, the weakest in this group, because I would multiply by 2 first, then add 1, is the 1. This 1 is being added, so what I'm going to do is subtract 1 from both sides. You must rewrite carefully. If you remember the order of operations, I told you that the rewriting process is important. This is why. You must rewrite what's left over. 2x came down, 1 went away, 7 minus 1 is 6. Now we have to get rid of this 2. This 2 is attached to multiplication, so we will use division to get rid of it. Those 2's cancel out, and x equals 3. Again, to check that out, you can simply go 2 parentheses 3, because that's what x is, plus 1, and make sure we get 7, which as you see we do, so I know I got it right. Again, the easiest way to know which one to move, honestly, is just through muscle memory. When you see it enough, you'll usually add or subtract first, although not always. But if you can't think about it, just imagine plugging a number in and use the order of operations. Whatever number you would do last is the number you will get rid of. For example, in this problem, the first thing I would do is add 3, then divide by 7, which means this is the number I want to move. Well, if you remember, whenever that number is on the bottom, it's being divided by 7, and the way I undo dividing by 7 is by multiplying by 7. Notice that I have a 7 on top and bottom of the fraction, so these two things cancel, leaving me with x plus 3 on the top, equaling 28. Again, I'll separate these so you can see it. So x plus 3 equals 28, and then I get rid of the 3, which is being added by subtracting it, and x equals 25. Again, to check this out, I type in the fraction button. If x is 25, I would put 25 plus 3 over 7 and see if this equals 4, which as you see it does, which means I got it right. As I said, typing it into your calculator on occasion just to make sure you can do it the right way is good, because when you take the ACT, if you learn how to use the answer to kind of plug it in, then you'll save yourself some time in terms of answering some of those problems. Now, we did a fraction problem before, but you might not have liked it because I had you divide by 2/3. This is almost like a two-step equation, and what I would do first is just get rid of the bottom number first. So if this is 2 divided by 3, what I'm going to do first is multiply by 3. And again, you can choose either way that works, but this is just the easiest way that I would do it, because this actually gets rid of fractions for you. So I would multiply by 3. That cancels out the 3's, which brings down 2 and x equaling 18, and then divide by 2, giving us x equals 9. Checking out two different ways. 2/3 times 9. Notice that it equals 6. Also, remember what we did yesterday was last lesson we divided by 2/3. You'll still see that if you do 6 divided by 2/3, you still get 9, which means that either way works as long as you have a system that works best for you. Whatever system you use, master it, practice it, get good at it, because you're going to need it and you have to rely on it. You never know what your problem is going to look like, so you need to be ready for it. The next one has x over 6 minus 3. Again, what I would do first in this case, because this is x divided by 6 minus 3, is I would divide by 6 first and then subtract 3, which means this is what I'm getting rid of. Because that is a minus 3, remember I'm going to move that. It's being subtracted by adding 3 to both sides. The 3's cancel out. X over 6 comes down, equaling 7. Now I want to get rid of the 6, which is being divided by multiplying by 6. My two 6's cancel out, giving me x equals 42. To check it out, again, you should be able to do this. I do 42 over 6, arrow out, minus 3. Notice I get the answer that I'm supposed to get. It says it should equal 4. It does equal 4. Therefore, I did it right. Last two, again, trick questions that you got to be ready for. 4x minus negative 2. I would not try to solve this yet because it has the double negative. Now, there is a Math XL question for this, and you have to actually do it the way I'm doing it, which is this. What I taught you was anytime you see a double negative, to switch them and rewrite it, which turns this to 4x plus 2 equals 18. So you must switch this around on the Math XL part. Now, whether you do it on the ones that you see on the test is up to you. But on Math XL, you actually have to type this in. Either way, once we get there, again, we know that that's multiply first, add second. So this is first. We will subtract 2. Those things cancel, bringing down 4x and 16. And the last thing we do is divide by 4, getting x equals 4. And again, if you want to check that out, 4 parentheses 4 minus parentheses negative 2 equals, you get an 18 here, you got an 18 up there. That tells me that I got it right. And then the last one kind of combines the two-step equations with that negative we were talking about. In this case, the first thing I would do is multiply by negative 3. Actually, yeah, I'd multiply by negative 3 and then do 9 minus that, which means 9 is the last number I deal with. So this is the first thing that should go. In order to get rid of this 9, you must understand that this 9 is a positive 9, and you do not subtract it to get rid of it. Or I'm sorry, you do not add it to get rid of it. You actually take a positive 9 and you subtract 9 from both sides, because 9 and negative 9 make 0. But be careful, because you must remember that this is a negative 3x that's coming down, equaling negative 15. If you don't know it's negative 15, make sure you type using your generic plus, negative 6 plus negative 9, and that will tell you what it is. Again, make sure you know how to use whatever tool you are using to get those numbers. What I was telling you here is that we could divide by negative 3 if that's what you want to do, but it is easier or safer, especially when we get into greater than, less than, to take this and switch all the signs first. So 3x equals 15, and then divide by 3. Therefore, x equals 5. To check it out, 9 minus 3 parentheses 5 equals, notice you got negative 6. Notice that says negative 6, and everything is where it needs to be. So attack this assignment with the understanding you're going to stumble a bit before you get your balance. Everyone does. It's part of the game. It's part of the growth process. You are going to stumble. Expect to make some bad choices, but that's going to help you learn to make the correct choice to experience. Pretty much whenever you are solving, and trust me, everybody that's in math right now has been solving for a long time. The way you learn is through experience. You see a problem, you mess up, you eventually stop messing it up, and therefore you've mastered that type of problem. So take your time, but work hard, because we are moving on tomorrow. You will get some time to kind of work next week or in the next few days coming up, but I do need to get you through the first 3 days of this so you can start to kind of see what's going on. But other than that, like I said, go ahead and go to your assignment and work hard. Again, I'm up at the desk waiting for you. Please make sure you ask as many questions as you need to. Good luck.